Welcome to 3 Steps to Sketch. In this video, we'll sketch a graph of the polynomial equation y equals x cubed minus 4x squared plus 3x using our method. So here's our template outline. In step 1, we'll find the intercepts, both x and y. In step 2, we'll determine the end behavior. So remember, that's just what does the graph look like on each end. And then in step 3, we'll put all that information together with a sketch. All right, so step 1, to find the intercepts, let's start with our x-intercepts. Sometimes we call these zeros. And to easily find these, we need to factor our equation and set it equal to 0. So looking at this equation, we can see we have a greatest common factor of x. So let's go ahead and take out that common factor and see what we're working with. Okay, so we'll just do a little bit of scratch work. We'll pull out x, and we're left with x squared minus 4x plus 3. All right, so then that quadratic is easy to factor just using traditional factoring. So the x stays out front, and to factor that binomial, we just need x and x. We want two numbers that multiply to give positive 3, add to give negative 4. So that's looking like x minus 3, x minus 1. So we've got our equation factored, and now we can set it equal to 0. So using zero product property, we basically take each of these vectors, set equal to 0. That will give us our x-intercepts. So here from the x by itself, of course, setting that equal to 0 just gives an x-intercept at 0 or at the origin. When you set x minus 3 equal to 0, that gives us x equals 3. And x minus 1 set equal to 0 gives us x equals 1. So now as we note these intercepts in our template, we also want to make sure we notice the multiplicity of each. And remember, multiplicity is just a fancy way of saying for each of these factors, what power is it raised to? And you can see very clearly each of these are raised to the first power. And we care about multiplicity because it will tell us how the graph behaves at that x-intercept. So we have 0, multiplicity, I'm just abbreviating with an m, multiplicity 1. We have 3, multiplicity 1. And we have 1, multiplicity 1. So this tells us that at each of these x-intercepts, our graph is going to cross through and continue on. And that'll be really useful in step 3 as we sketch the graph. So we'll pause on that, come back to it. Now we need to find our y-intercept. Remember, this is very easy. Simply let x in the equation equal to 0 and then simplify. Okay, so seeing if we let all the x's equal to 0, our y-intercept here is 0. And that makes sense because we have that x-intercept of 0 as well. All right, now we're ready for step 2. Let's determine our end behavior. And to do this, we need to look at our leading term. So that's the term with the highest exponent. So we'll just record it right here. It's x to the third, okay? And we need to know two things about this to make our determination for the end behavior, or how the ends look. First, we want to look at that exponent, that degree, to see if it's even or odd. So since it's a third degree polynomial, it has odd degree. So it'll have odd behavior or opposite behavior at its ends. This is something I like to go ahead and be thinking. And the leading coefficient is positive. Okay, so it'll behave like our basic y equals x cubed polynomial. That is down on the left and up on the right. So again, note that odd degree gives it opposite behavior, and then the positive means that it's down on the left, up on the right. Okay, so with the analysis we've done in the first 2 steps, we're ready to sketch. Let's just put some of this information on the graph and it should all come together very seamlessly. So we know we have our x-intercepts. I'm just going to mark on this open axis. We know we need to label 1, 2, 3. Okay, so we really care about the 1 and the 3 here. Let's go ahead and mark those x-intercepts, and here as we put our x-intercept on the origin, that note that's also the y-intercept. Okay, so we have our 3 x-intercepts here. Now we can put our end behavior onto the graph. So on the left, we know it should be ending trending downward. on the far right, it should be trending upward. And then I think since we're just sketching here, it's pretty easy to see that we should come through our x-intercepts, come down, come back up. And remember, we talked about that multiplicity. Each of our x-intercepts has multiplicity 1, and that's how we know it has this crossing and continuing through behavior for each of them. And so notice now we have a very nice sketch of our polynomial equation. And notice that the y-intercepts of, say, this maximum here and this local minimum here, those aren't exact. You need more advanced methods in calculus to determine those. All we want is a basic sketch of the polynomial, and that's exactly what we have. All right, so hopefully this 3 steps to sketch method for polynomial graphing really helps you. Use this template. It'll be a really good guide. You'll become an expert in no time. Be sure to check out the video description. There will be a link for more examples, and thanks for watching.